Hold on.
Look at the draw. Tell me whenever.
Will do.
And then they took off. I said, boy, you guys know it's cold. They said,
Wet Creek.
We're good. Yeah, we got 10 so far. People are slowly signing in, so
We'll give it another.
I'm recording also, so hey, you don't mind if I record this, do you? You sure? Okay, thank you. Thank you. It'll be with Benoist and contractors on Benoist, so.
Chris, you're so woke.
Okay, okay. Yes, sir. Yes, sir. Thank you.
You're gonna look at great cats. You're gonna have to make sure to say the rough. Road couple more now. But I don't think it's the DDI know the whole Barry. No, it is. All right, guys, we're gonna get going. I think I know everybody in here on paper. That's Chris has lost us. If you tell him all he's like counterpart itself. He's running this room because I don't want to run it.
Morning.
Janie from marketing. Guru. He's back there. Everybody knows Peter. Anyway, without further ado, this is Alan Coggins. He's the inventor and manufacturer of this new revolutionary electric furnace. Take it away, Alan.
Well, thank you guys for having me out here today. I really appreciate it. Any chance I get to talk about this, of course, I love it. So just kind of give you a quick background on myself. I went through actually tech school, South County Tech first, and then I got into the sheet metal workers. At that point, I finished both apprenticeships, an 8-year apprenticeship and 4 years, if you will, service apprenticeship and the sheet metal side. Carried 2 journeyman cards under my belt with that. I was an air balancer and water balancer for quite a few years after that as well. So kind of did everything under the sun. That's kind of got what got me thinking like an engineer, if you will. And then, my first energy invention was the nation's first hybrid LED street light. All the LED lights you see on the roadway today, I'm the guy that kicked that off in the country. I just didn't sell that patent for enough money, otherwise I would be in St. Croix instead of St. Louis. Mildly joking there, but, you know. And then, so I came across this a few years back. I actually came across the heating panel. And the heating panel itself is utilized in an industrial application and has been for quite a while. And then that's when I had the aha moment, the light bulb went on. And I started testing, creating everything else. Like I said, I just like to blow stuff up sometimes, so there's that. Yeah, and then one day I went to her and I said, I really got something that's working here. I said, I'd like to take out our brand new gas furnace. Then she thought I was crazy. Somehow she's still with me today. But we took out the gas furnace and I put one similar to this end, but it was made out of about 1/4 inch steel, all of that things. I didn't want to do that inventor guy who burns his house down, you know, kills the whole family. Needless to say, it was a small firebox. You know, nothing would have happened. Fast forward a little bit here. In 2020, we shot a documentary with PBS on a show called In Depth with Lawrence Fishburne. If you guys have seen that, it's still up and still out there. They still have it, but this is the corporate segment that they did for us. This is a 4-minute video. I'm going to play this first before we start digging into everything a little bit more. This will kind of give you a 30,000 foot overview.
In the last 100 years, we've witnessed groundbreaking innovations and solutions all across the globe, from advancements in medicine to the implementation of the World Wide Web, and even landing on the moon. The last century has completely transformed how we live our lives on a day-to-day basis. When we go back to the comfort of our homes, little has changed since 1919, when the first furnace was invented and patented by Alice Parker, relying on decades-old technology to heat and cool their living and working environments.
There's the big difference between an electrical heating system that's over 100 years old in our system. Well, it's done by a few different processes. We utilize a solid ceramic thermal mass inside of our furnace compared to the conventional electric system, open coil wire. It's very much like a toaster. However, the electrical system is a toaster with a blower on it. Our system, we utilize the infrared spectrum of heat, control algorithms, and some special design features in our furnace in order to create the 41% energy savings that our furnace has been verified to do.
Cocoon systems are greener. Let's face it, the electrification of North America and really globally, and trying to wean off of carbon-based fuels. This is the only furnace that can deliver gas-like temperature comfort, yet use 41% less electricity than a standard electric furnace.
I have always been one to try to conserve where I can. And so I felt like if this system was capable of conserving energy, then I was on board with it 100%.
We're seeing savings on both ends of the spectrum. We're seeing savings on the air conditioner because we went with a more efficient unit when it was installed that the gentleman had recommended that we install. And I've noticed energy savings on both ends, even though the furnace doesn't really apply, obviously, in the summertime. The air handling of it and the efficiency of the blower and everything else is definitely saving quite a bit of money.
Right now, if you're sitting in a 2,000 square foot home and you're heating that house for $1, that same dollar will now heat a 3,500 square foot home. Imagine the savings you're going to experience in your 2,000 square foot home.
Change isn't on the horizon, it's here. Created by HVAC Magazine's Inventor of the Year, Alan Cox, Cacoon systems are the only UL verified solution to save you over 40% on your bill with gas-like comfort.
It's not just one particular thing that makes the magic happen in order to save that kind of energy. We basically take that energy and mold it and use it in a more usable fashion, which is also in return more efficient.
The Cocoon systems are easy to install in that they're modular. So where they've got tight areas in a crawl space or in an attic where it'd be difficult to get a traditional system in, ours can be broken down and easily disassembled and reassembled in small places and can be built in sort of a building block method to where the egg coil can be on top, can be on the bottom. There's just tons of flexibility and scalability of the furnace. You don't have to do annual inspections of the burner because you don't have to worry about your flue being potentially plugged up by a squirrel or something like that, there is just less maintenance with the system. So therefore, your cost of long-term operation is less. Life expectancy of the furnace is going to be greater because you don't have the risk of the open coil system burning out or the inside of a combustion chamber of a gas furnace cracking or rusting, which they ultimately will do.
Located in Missouri, the team at Cocoon Systems is dedicated to saving you money and helping communities on both a local and global scale.
When the COVID crisis broke out, I really tried to look for a way in order that how can we help? How can we help the community? We were able to build a heating chamber that you can put equipment in order to sterilize it. And we are currently waiting on an FDA approval on our COVID killer system.
The Heating with the Heart program is a program that we've implemented in our corporation to not only give back to our community, but also leave a legacy for our community and our children.
To learn more, visit cocoonrevolution.com or call the number on your screen.
I got to do this. So that right there is the first absolute sale we ever did, and my son helped me deliver it. And so when we shot that documentary, of course, wanted to pay homage to my son. I lost my son in 2019 to an unfortunate 18-wheeler accident. So that's why I had to leave that on there. So let me tell you a little bit about our history too. So, we were going through and, going through UL testing, getting all this stuff, getting the verification testing done. And then, of course, our world shattered. We lost our child. And then right after that, when you pick yourself back up, if you will, or learn to live every day, you start to make it happen. And then you realize that, okay, we can do this again. We can still breathe. And right after that, boom, we get hit with a pandemic, a worldwide pandemic. So that's one reason why you haven't been seeing our systems a lot more or hearing more about us. It's just we've had one thing after another, and we're finally on a good track here and on our way. So let me go over and kind of actually really get into depth here of what the system is and how it works and so on and so forth. So just because you see yes, that is a Goodman stock pitcher. We've hooked to just about anything and everything thus far. We've hooked to Goodman, Lennox, Carrier, Train systems. On the cooling side of things, airflow is airflow, right? And we just need to know what is happening. I like to run my systems on the cooling side about 350 CFM per ton to 300. However, California will not allow us to run 300 CFM per ton. The reason why we do that, of course, is the extra dehumidification that you get from the system. So in our furnace, I'm kind of old school that, pretty much anything over 2,000 square feet, you need two systems in regards to that. I mean, we can put 5-ton air conditioners on these. There's a number of different ways to do it, but I think when you start really talking with your customer and everything, comfort, redundancy, and everything else, I'm a bit old school in that fashion, but it is still possible. What is Cocoon? We're going to go over how does it work, installation. We did recently just sign a deal with Unico, where they are now implementing our technology inside of the high velocity systems. The high velocity systems had a big problem. You get up into like a 20 kW, electrical need or electrical furnace need. They have such a high pressure drop across them because they're shoving 10 pounds of crap in a 5-pound bucket, And so we actually have a better heating solution for that technology as well. So what is Cocoon? We're the first revolution in electrical heating anyway in the last 100 years, a path to energy independence. When we go to the trade shows, we've been to AHR a couple of times. We actually have a small shipping container that we send with us, a 6x6x6 that we load up with batteries. And then I take the furnace down there and I run the furnace off grid at the show. I set it up to where people are walking by, and as they're walking by, it's blowing hot in their face, and they come up and, what is this? Is this a gas furnace? No, as a matter of fact, it's running off of electricity and it's running off grid, which has been a real big, real big deal for us. The other thing that's happening there is that we are we're in the process of developing and implementing a battery system. What we're looking at is the heart of the home, right? a path to energy independence, right now, if you need, if you're looking at solar and whatnot going on your house, it's, you're $50,000-$60,000. We're looking at a way that it can be incrementally done, so that the way it's affordable for everybody. Okay, so about 6 different things here. Actually, we were patented in early 2019. We finally got our patent, and I don't know if anybody knows anything about patents, but when you file for a patent, you put in like 20 claims, right? And then the patent office comes back and they start throwing them out after that. So our patent was granted on 12 claims. That means there's 12 things in our patent that is completely new, if you will, and inventive. Out of those 12 claims, 4 of those claims are what they call independent claims, where we are filing for 4 new patents as well. So our patent's pretty strong. But what is some of the big difference here in conventional systems and ours? So the thermal mass, it's like a big hot rock inside of the furnace. Okay, once you have that rock heated up, you don't need the same amount of energy in order to keep it hot. If you want to maintain a steady state, then yes, you got to constantly throw energy into it. But what we do is we play upon the characteristic of that thermal mass, and we burst energy into it, trickle energy into it. There's a number of different things that we can do there. The infrared heat. So I'll go over that in another slide here. We are running on the infrared scale at a different spot compared to where conventional electric furnaces are running. And I'll get into that a little bit deeper here. The modular and scalability with special design features. So unfortunately, part of my time in the trade and maybe some poor decisions as a young man, I have degenerative disc disease in my back. So needless to say, all those years of moving those 200-pound furnaces up and down the basement stairs did not do me well today. So I wanted to make sure that we could make this easy, much more easy for your installers. So that way when they go home, either A, they're not hurt, B, they're not wore out. They still got time for their families at the end of the day. Now I'm going to get into that more in depth as well. The controls and the control algorithms. Again, once you have that thermal mass heated up, or how much thermal mass you have inside of the furnace, and I'll show you that here in a second as well, is depending on what we can do with that energy. How can we manipulate it? Maybe we heat it up at a higher temp, and run it at that point. Or there's just a lot of different things that we can do with that when you have a lot more of the thermal mass and everything inside the furnaces. And I'll show you that, like I said. The controls, we do have some new controls in here that are, I think, a lot easier and a lot better than your typical furnaces, both gas and conventional electric. Okay, so the thermal mass, what you're looking at here is inside the furnace here, and of course there's one up here. There are 4 hot rocks, if you will, or 4 panel emitters is what we like to call them. You got 1, 2, 3, and 4. There's 2 panels underneath the mesh there. So once we have that heated up, again, we can burst energy into it or a number of different things like that. Not to mention we have more airspace. So heat is compounding, right? And when you start adding more heating chambers on here, that air molecule spends more time inside of that bonnet, if you will, the bonnet of the furnace, and it is manipulated a lot more as well. Okay, the infrared spectrum, right? So in the lower left there, you see an example of a heat strip, 100-year-old technology running. That runs, if you look in the upper right corner here, this is the infrared spectrum. So visible light, you must have more energy. We do not create visible light, okay? So already we're saving energy right there. Visible light's going to be right at a short to above the shortwave infrared spectrum. We're running in a medium to long wave. We can drive our panels into shortwave if we want, or visible light, if you will, but sometimes there's just, really call it 90% of the time, there's no reason to do it unless we're looking at like maybe an industrial application or something along those lines. So again, no visible light, medium to long wave, and we have more surface space for heat gain. The one thing I'll say too real quick is our face temperatures of the front of these panels, you're going to be somewhere between 600 to 700 degrees on startup, depending on the model. And I'll go over the duty cycle here in a second, how the furnace runs there. And then when your blower kicks on, we're going to be running about 350 to 450, somewhere right around in there, as far as the temperature of the panel. The longer it runs, the hotter that panel gets. Okay, so the modular and scalability with the design features here. So again, this is like building blocks, you know, Legos, if you will. So we've got a few different models and you'll see that here in a second. As I was saying, you know, if you've got a larger house or you have a reason for, maybe they just really want that comfort aspect, you know, the more thermal mass you add inside of that furnace, the better off you are as far as what you can do with that energy into that home. Not to mention, oh yeah, we do have a zero clearance install rating. We still recommend 1 inch. That's just good common sense. And you know, put it in tight spaces, the whole 9 yards. If you need downflow furnace, you take the blower, flip it over. That's it. So here's some of the series, if you will, that we have, or the different models. Our compact series, kind of like what you're seeing up here. You know, and again, you can take that same furnace, whether it's the 1800 or the 1400, you can install it in a 400 square foot apartment, and you're not going to oversize the furnace, because those heating panels really kind of do act almost like a variable speed, if you will. You can heat them up, slow them down, everything else. Okay, the special design features in here. So inside of the furnace, inside of the chamber anyway, all the heating chambers, it's a double wall. Anything that's inside of that double wall is under a negative pressure. So what we're actually trying to do in the blower housing, as you see in the middle picture here, we have a small recirculation, if you will, that sits right over that. And so any of that heat that normally would have been escaping out of the sides of the furnace, because that's technically what they say, how they rate the efficiencies on electric furnaces right now, is basically what is your furnace doing minus the jacket loss. So what we're trying to do is recapture that air that normally would have been escaping, say, into the basement or attic or crawl space, and put it back into the airstream. And we're creating a mixed air temperature in the box. And here's a video showing that. What you're looking at here is the air filter. You'll kind of see the camera comes down here in a minute. You can kind of see the air filter up there. What you're looking at is on the right-hand side, that air is coming down and creating that mixed air temperature inside the furnace here. So then you're just like in your when you're balancing on your rooftop systems, you know, you always got to have so much outside air to come in, you know, for your commercial buildings. And they're always pulling in the air from the return, creating a mixed air temperature. So you're never heating or cooling from 0 or 100, if you will. So, okay, here's the controls and the control algorithms. So this controller is a Mediacon M172. It's made by Schneider Electric out of Belluno, Italy. This thing is a small computer, all right? You can do a lot of different things with this controller. You've got the Cat5 connection for your building management systems. We have a micro SD card in there for your data logging. And then, of course, a USB connection. And one of the nice things about this USB connection is that if you thought there was a programming issue, we give you our program on a USB stick. You plug it in, cycle power to the furnace, it reloads the program. You're off and running. So far, knock on wood, somewhere, there we go. We have yet to have a programming issue with all of our systems out. Most of the time, it's going to be just like any other board where you got power coming in and no power going out. Well, you know, you might have an issue with the board there. Everything's color coded and the wires, the whole 9 yards there. I really tried to kiss it, keep it simple, stupid. You know, I remember the days of going out working on the old Coleman heat pumps and everything else, and you pull everything apart and it's a big rat's nest. I wanted things color coded, numbered. So that the way, if you got a first year apprentice or you got a brand new guy in the trade, as long as he can read a wiring schematic, there's no reason why he cannot work on this furnace. It's basic electricity 101. The control algorithms. So what you're seeing here at the bottom of the screen is like basically our duty cycles, if you will. And I'm going to get into that. When we start data log, okay, so a lot of your smart stats with data log as well. So that's our first area where we look at the data, because how is the furnace affecting the home? Ultimately, that's what your thermostat is saying. And then you can look at those energy curves, right? You can see them like with conventional systems, you get a lot of peaks and valleys, right? comfort and energy have not gone hand in hand for quite some time. And we're starting to bring that back, where comfort and energy can go hand in hand. And so first we look at the data that's on the smart stat. And then from there, if we see an issue or there could be something else going on, well, then we can pull the data off of the furnace and we go, okay, what's happening inside the furnace? You know, let's face it, you know, troubleshooting and programming are almost the same thing. If, then, else, okay? Programming is just like that too. So there's a number of different things that we can do with that and we can do with this data. What we like to do is gather about 2 years of data if we can, and then we can start to customize the furnace for the home. Now, of course, you're going to want to charge your customers an extra fee for that as well. So that's how you're going to make the money on that too. Let's see here. So again, color coded, everything else, the data logging. I wanted to try to put this on here because our fan speeds that we use a Needex motor that's in there, the ECM motor, and it's a 24 volt on Gen 3. You can get it on the Generation 3 motors. You can get up to like 10 or 15 speeds, whereas like the Gen 2 was like 5. We basically have 3 set up here. We have a fan speed for our primary heating. Then we also have a cool down. And let me explain that a little bit here. So when we are, when you get a call for heat, right? Thermostat's ready to go. We need a call for heat. The furnace will kick on for 1 to 3 minutes, depending on the model. And you can actually set the warm-up time through the controller as well. That is very doable. That's something you can do in the field. And then after that 1 to 3 minutes, our blower motor kicks on at our primary speed. As soon as the thermostat's satisfied, we then shut the power off to the heating panels. Now you still got those big hot rocks in there and you still got all that energy, right? So, you know, energy cannot be created nor destroyed. It only changes from one form to another. We are changing that form into a more usable energy as far as for the heating application. We're not changing it into light. Either A, that energy is being put into the heating panel, or B, it's being put right into the air at that time. So now that you have this big hot rock in there, what do you do with it? Well, we slow the blower motor down and then run that speed for another 10 to 20 minutes afterwards, which again is settable inside of the controller. I'll show you, I'm going to play another video here for you. And during the process of commissioning the furnace, right, you don't want to just install it and, you know, walk away from it. You need to make sure the thing's running right. I recommend that on any furnace, whether no matter whose furnace you're putting in. And then just make sure the customer's getting what they're paying for, if you will, and try to get them the best energy that you can out of the best energy consumption and everything, and comfort out of the furnace. But let me show you how to kind of navigate the controller here.
And this is going to be a quick tutorial of the menu options on our Cocoon 172 and the Cocoon furnaces. So if you click OK, it'll give you a light, backlight. You're going to click the right arrow button to scroll over to any new menu. And at this point, this is your landing page. It gives you basically your I/O statuses, your set points, the data logging, clock, how to set the SD card and the memory card. We'll go through that in another video later. And then actually this here is for USB, where you could plug in the USB up top up here and download your data files into your USB without having to remove your data card. So if you want to back out of any menu, you're going to hold the left arrow button down for about 1 second, and it'll take you back to your menu from there. The red light up here is indicating that there is no memory card available or memory card inside of there. It's just a quick way and you can look at it and say, okay, does it have one in there or not? Because since they're micro, they're kind of hard to see. And this is going to.
Okay, some of the other differences that you're going to see in our furnace that I think you'll find that your service techs and everybody's going to like are these terminal blocks. So before, you know, everybody's got the screws and you got to screw them down, and then they get shipped, and then they get bounced around in the truck, bounce down the stairs, everything else, and you have, you know, loose electrical wires, right? With these here, these terminal blocks, they're 250 pounds of pressure to pull the wire out of that. The only issue that we have had with these is if somebody is stripping a wire and they strip off too much and they strip some of the wire itself off, and you put that wire inside of there, this little gate right here, when you stick that screwdriver in, this pops up, you put your wire in there, and if that wire is, you know, they cut half the wire off, that little gate could cut the wire. We've only seen it once or twice, but, you know, it was field done. It wasn't even, it was again, not the furnace issue, but a technician issue. So these things are great. You know, when you're doing like your general maintenance, just give them a little tug. If they're not pulling out or they don't seem loose or anything like that, well, then you don't have to do anything else with it. You just want to make sure that they're in there and they're snug. That's it. Oh, also, they're all numbered too. So, I mean, again, you know, if you have to take something apart, you know, you wire that, you can label that wire and boom, you're not having to sit there and read through a schematic to get it done. The installation portion of this, it's very similar to almost like a gas installation and also an electrical installation. And let me expand on that. So on our furnace here, we do not put bottoms in them. But you can cut the sides out just like you would with a gas furnace. So you can set the furnace on the floor. What we do ask is that you still put a bottom in it, so you're not drawn or somehow seal that furnace to the floor, if you will, whether you're using silicone or whatever the case, just to make sure you're not pulling in that air, the basement air or the attic air or anything like that. If you want to stick them up on a box, you can. That's not a problem. It's going to come down to, you know, kind of what model you have and what solution do you need? Let's face it, you know, you go to each home, well, one's got a 7-foot pour, the other one's got a 10-foot pour on the basement. And so that's going to really kind of decide what you can do or what system you need to use and all of that. This picture here on the right that you see, so this one's down at Lake of the Ozarks. And that the gentleman who installed this, he put the A coil underneath it. That is a draw through coil. You know, so what's happening there is that we're actually cooling down the rocks now and during the cooling season, if you will. And we are finding that we are getting a small uptick in efficiency, if you will. We have not had that verified or proven by Underwriter Laboratories yet, but that's our next place that we're going. Because, you know, now instead of having a hot rock, you're getting a cold rock. And so you're able to kind of play on that. It's not nearly as linear as it is like with the heating side of things, but we are getting a little bit of an efficiency improvement there. So these are a couple of systems that we have. The one on the left is up in Michigan and the one on the right is here in St. Louis. What you're looking at here is a compact system with no blower in it and no, the whole blower plate, if you will, is removed. Basically that other, this piece right here, which normally would have been the blower, is ductwork, you know, so I mean, to get right down to it, it's just metal. It was easy for that job and for that up there in Michigan, that's the way they wanted to use it. So we're actually drawing through the furnace and then running it into their blower system on both systems there. The one on the left is a single heating chamber system. The one on the right is a 2 heating chamber system. Comparison, again, this is kind of for demonstration purposes here. We do have real world testing data that shows we can rival the operating cost of Geo. We are not beating it, but we are rivaling. When you pair us with a high efficient heat pump, you're getting the best of both worlds without the high installation costs for your customers. We've actually seen we're competing against Geo quite well right now. We seem to be beating out the competition, if you will, on that because nobody wants to pay that $40,000, $50,000, $60,000 or whatever it is for that HVAC system that A, has no return, and B, normally you have to replace that equipment before that Geo well is done and all that kind of stuff too. Benefits, you know, we're quieter, comfortable, longer life expectancy. The panels, we've got panels that's been running for 30+ years at this point. No carbon monoxide, no gas. You don't have to worry about venting the furnace or anything along those lines. So less holes in the house, all of that, less flashing you guys got to do as well if you're running through multiple floors. Program the controller capable with building management systems, cleaner, less polluting, and also, like I said, a path to energy independence. Step number one, how do we bring a customer to energy independence, or how will I bring a customer to energy independence, if you will? First step is to put the furnace in their house. Start gathering that data. See what's happening with the house. What is their heat loss, heat gain, so on and so forth. How is the furnace reacting to the home? Then from there, we can start sizing a battery system and solar for just the furnace and the air conditioner, not the whole house. That's kind of how we're taking the approach to that, if you will, whereas a lot of these other companies are, let's run the whole house, and you need a much higher upfront cost on that too. We're made in the USA, and we're also made in Mexico. And we're looking at opening up a facility in Europe as well, because the European market has been exploding like crazy for us. I gotta say, probably thanks to Russia for that, since they threw the world into an energy crisis. And so, yeah, it's I know California, as of January, there will be no more new gas installations. However, they have an issue where they also said no conventional electric furnaces. So right now, we're currently trying to also expand that market for us too. And Europe as well, they have laws on the books that will be no more gas. Everybody's getting away from fossil fuels, and it's really becoming re-electrification of the world again. And so, yeah, and also the East Coast too. East Coast is on its way. New York has passed some of those laws. My purpose in saying this, it's not if it's going to happen here, it's when. As you guys know, East and West Coast we're usually 4 to 6 years behind them before we get something, or whatever the case is. So again, not if, but when. Yeah, so better margins, if you will, for you guys. So we are not the Goodman of the industry. We are not the cheap furnace. If you have, or if somebody is wanting to sell on price, we may not be a fit. I'm okay with that. We are selling the Tesla of the industry here, okay? Which also means you can do that too. So a furnace, now you can demand a higher price for your furnace, all of that to your customer. And, again, you're not just selling a product, you're selling a solution here, and actually a long-term relationship with that customer too. So yeah, this is just one of our distributors in Newfoundland. I have furnaces in Newfoundland, Italy, 2,000-year-old castle in Italy, furnaces in England, East Coast, West Coast. Yeah, pretty much kind of all over, if you will. I think we're getting ready to head to Hungary as well, of all places. Never would have thought, call it 15 years ago, I was in a truck and running service and doing installs and everything else, and never would have thought my HVAC career has taken me around the world. So that's the presentation there. Do you guys have any questions?
How long does something like this last?
Yeah, so 30 plus years. Yeah, I mean, of course, your blower motors aren't going to last that, and your contactors aren't, but the heating panels, the guts of the furnace, you're going to be 30 plus years.
What's the warranty?
We're 10. Unfortunately, but I say that. I mean, it's like, Goodman and all these guys, they keep just throwing more warranty at it, and I don't agree with that. It's you show me a blower motor that's going to last plus that. I haven't seen one yet. So either way, your customer's paying for it when you get right down to it. But that's what the industry standard is, so that's where we're at.
I have a little more technical question, if you don't mind.
Sure.
Heat anticipation. Your algorithms, I noticed those blocks stay really hot for a long period of time. Do we do any type of anticipation with the algorithm after it's been in for a while, that we can anticipate that the time it takes that to cool down, so that we're not just overheating the home?
So we don't overheat the home. I mean, you could put 3 of these heating chambers in a 400 square foot house and you're not going to overheat it. Because of that thermal mass, you're not getting those peaks and valleys.
Mhm.
It's more like a gradual wave sign, if you will. It almost mimics what an alternating current wave looks like, if you will, and that's kind of what our energy consumption looks like in the home as well.
So you're basically saying those cool down fairly quickly?
10 to 20 minutes, depending on the model. So what happens is that on a conventional system, if you continue to overrun that thermostat, right? And you continue to have it, yeah, you're going to overshoot that stat like crazy. When we shut that power off to the heating panels, immediately they start to lose their capacity. You know, that you start to lose it out of there. So what happens is we get a nice gradual curve back down to 0, if you will. So we're continuing to put those BTUs that normally would have not been, they would have been light, if you will. We're now putting them as heat into the home, but at a degraded rate. So what we find is that, let's say a conventional system that's in a home that you're going to get 10 to 15 duty cycles per day, we're now going to be like 8 to 7, you know, or whatever the case may be. Because of that extra time at the end there, you're putting those BTUs into the home, you're keeping that comfort more level or closer to that 72 degrees, if you will, instead of those peaks and valleys. We have yet to see one that actually, you know, overshot, if you will.
Okay, and with that being said, on rough installations, how do those panels tend to hold up? You know, no offense, guys aren't easy. They're not, you know, are you seeing any failures as far as breakage? You know, how do they hold up
You
in
know,
that aspect?
no, not necessarily. I mean, yes, you can, you know, you can damage them, of course. You know, you drop the furnace, you know, I mean, yeah, something, any furnace for that matter, you know, you can damage something, of course. We have had them jump about 4 feet in the back of a truck. You know, as far as you put them on a pallet, especially when they're going to Newfoundland, you know, a pallet can jump up to 4, I think it's 4 feet inside the truck there, especially if it's like sitting on the back end. We've done the drop tests, the whole 9 yards. They're pretty robust. You know, I remember the times of, you know, throwing the furnace in the van and taking it through and bouncing the thing down the stairs and everything else, you know, and when you don't know any better, of course. You know, but yeah, I wanted to make sure that we had some redundancy there. The other thing too is, like, let's say if you guys got a salesman who was trying to sell these or whatever, and he didn't do a load calc on the house or anything along those lines, and he undersizes a system. It's not, you don't have to necessarily pull the whole furnace out and replace the furnace. You can 12 screws and undo 6 wires, you're inside the guts of this furnace. So I wanted to make sure that the days of, oh, here's your 4.5 to 8 hour heat exchanger change out is done. You know, people don't want us in their homes. You know, we're invading their privacy, all that kind of stuff. So I wanted to make sure we could get in and get out. You know, if a catastrophic failure would be a heating panel that failed, but you're in and out of there within an hour, you know, to be able to replace it.
And then I have a Zoom chat question, if you don't mind.
Sure.
From Jeff Barnacle. He would like to know, how do you modulate the input similar to SCR?
How do we modulate the input to SCR?
Or he says, I apologize. He says, how do you modulate the input similar to SCR?
So we are not there yet as far as release that to the public, if you will. That's
Okay.
what we're still developing as far as, you know, whether we trickle that energy in and that kind of thing.
Gotcha.
Yeah, some of the equipment in order to do that's needed. I'm not ready to put my name on it yet.
I got you.
Yeah.
I got you.
But right now it's time and temp, if you get right down to it, just like anything else.
Okay, time and temp.
Mhm.
And I do have one more question myself. I don't mean to blow you up.
No, absolutely.
What about zoning? How does your controls work with, you know, other zoning controls? I mean, is there a issue with like, who takes the lead, that kind of stuff? I mean, do you see much problem?
We haven't had any issues with any of that yet. You know, that's actually kind of one thing that we're writing in our new programs into the furnace too, of like kind of that zoning aspect, and then also kind of like what you're saying, who takes the lead, who's the lead one, and we're doing that same thing with our heating panels when we talk about, you know, okay, depending on what model it is, you know, in the 3000 series. Let me pull that up real quick. So in this 3000 series here, I'll just leave this one. Yeah, there we go. So like in this one here, so we got a number of different solutions that we can do here. We can drive this heating chamber where all 4 of them come on, and then we can alternate 4 panels or alternate 2 panels back and forth with this guy. Same thing with that. We'll drive them completely on. There's a number of different things that we can do there with the furnace. And that's actually one of the things that we're looking at now. It's like, okay, so heating chamber number 1 becomes our primary for X amount of time. Then we go to heating chamber number 2. So that way you're not, you know, kind of the same thing. So you're not burning one out, the others are good.
My understanding is there's really 2 furnaces, right? There's one that goes up to 18,000 BTUs and another one that goes to 2,000.
Well, it's not 2000. So what I did, you know, when you go from a truck to manufacturing and, you know, you're out there, I mean, yeah, I was selling and, you know, throughout my career, as soon as you start talking BTUs to homeowners, eyes go closed and they don't understand it. Most of the time the homeowners understand square footage. And that's kind of where our nomenclature started to come from. It was like, okay, this furnace is, this furnace is good for 1800. It's really that one picture that I showed there. We've got about 3 different lines. But you know, you can figure we're a direct replacement for anything that you got out there, if you will.
So is there more chambers in the bigger one?
Yep, just like this one here. So like this would be your compact, and you got 1 single heating chamber. And then this 3000 series or 3800, or, you know, we've got a couple in that 3000 series there. Is just, and it's really to identify that, yes, we have more thermal mass inside of that system.
You put another box on top.
Yeah, you can put them on box. You can, or on the top, you can actually put one on the return side as well. I mean, with these panels, unlike conventional electric, if you got no airflow on them, you'll burn those coils out real quick, right? Or possible. With these, I mean, you could technically run this thing like a gravity furnace. It's not recommended by any means, but we have panels where we have no airflow on them whatsoever. So the redundancy is there as well, that like, let's say during a duty cycle, we had a power outage. Well, you're not going to turn around and blow, you know, or kill the coil because it's in mid cycle. You know, you might trip a limit, you know, that's possible, but you're not going to destroy the panels.
So basically, delivery system is optional. I mean, we can size, we can add or size depending on what delivery system we already have. So,
Yep.
Okay, all right.
Yeah. I mean, of course, you know, our blower motors, we're 1/2 horsepower, 3/4 horse, right in there, you know, as far as what you're going to get. But we're still staying with that 18-inch frame or 18-inch wide by 24 depth. And again, it's just like building blocks. If you need more, either quicker heat recovery time or more capacity, add chambers or add hotter panels, if you will, that, you know, if there was an issue with, like I said, with like a salesman that, you know, didn't.
But basically like a hospital system where we have a chiller and, or whatever, we can individual room.
Yep.
It can be a separate duct set, you know, for, you know, and thermostatically controlled for each room, that kind of application.
Like reheat boxes and
Yes,
all
sir.
that. Yep, absolutely. Yeah. We perform well in those scenarios too.
Every picture I've seen you put up there, and I'm just simple sales, so forgive me, I'm not a technician, but you're talking about electric furnace, then you have to put a coil on top, but an A coil, right? And I haven't seen any with an A coil on top in your pictures, but that's what you're talking about, putting an A coil
That's
on
one.
top of the furnace.
Yep.
And then up to the, okay.
Yep, A coil on top. So, you know, one reason why they don't put A coils on top of electric furnaces is because when they leak, not if, when they leak, you're going to burn out a lot of that stuff. Well, so early on, I needed a place to test. Didn't have $4 million to build a testing facility. So I went down to Crystal City Underground. You guys are probably familiar with that, in Festus, 450 acres of cave. And I had an endless supply of 55-degree air that I could test my furnace with. Well, sure enough, we get flooded, and the furnace had 8 foot of water above it. And so what I did, I came in, I changed out the blower motor and the electrical parts, left the heating panels in there, and the sucker fired right up. Stank like crazy because they were covered in mud. But yes, I mean, that's actually one area that we're trying to get with the insurance companies, that if your basement is flooded and all that kind of thing, maybe there's, you know, something that can be done there with the insurance side.
But that is the regular installation. Are you telling us that you'd rather have the coil, A coil underneath?
You could do either. It really comes down to what, what solution do you need? If you don't have the ceiling height in the basement or whatever, well, then yeah, you could take that A coil and do a draw through coil. We don't have any issues with that. The one thing that I will say on draw through, and I think that's any furnace, if you will, when you come in through the side of where the blower motor is at, that blower motor is going to see a lot more issues, a lot more humidity, the whole 9 yards. And yeah, you could have a quicker problem with your blower motor if you're drawing through the motor itself. You draw through on this side, the motor's on that side, we don't see those, we don't see that quick degradation of the motor, if you will, or quicker degradation.
I have a question on, it has to do with AHRI rating.
Yep.
Are you in AHRI? Are you in there?
So currently for electric air handlers, there are no AHRI ratings. It comes down to efficiency aspect of what is the furnace doing minus the jacket loss. That's your efficiency of the furnace, because DOE blankets everything, all electric is 100% efficient. Our data has proven that wrong. Our furnace has proven that wrong. And that's where we're at with DOE right now, is to say, hey, we're a whole new animal. If you ask a fish to climb a tree, you're going to get that same result, And so what we do with the AHRI ratings is we do a coil rating. And that's how we've been getting the AHRI coil ratings, basically, which is the A coil and the condenser,
So are you saying you get a rating on a system? If this is part of the system.
It would be a coil rating, but I think that's changing as of January, if I'm not mistaken.
Right now, if you put 15 series heat pump on there, that's rated by itself without the air mover.
Yeah.
It has an age, that's what it's trying to say.
Coil and the outside
Yes.
unit.
The coil on the outside unit, AHR rated without the air mover. So the air mover's got nothing to do with that. Now, if you put a 14 SEER on there, which you won't have next year anyway, that's what's gonna go away, is 14.
Yeah.
Then you don't have an AHR rating, because that is rated with your blower and your furnace.
Maybe that's what I was doing.
That's what
I was
you're
looking at
thinking.
14 series system.
Yes,
I
you are
couldn't
gonna
find
have that.
I couldn't find a coil outside unit match that would go on top of that, but I should look at the 15.
You look at a 15 or 16, and we're rated that outdoor unit coil alone.
That's why I couldn't find it.
Yep.
Okay, that answers that question.
And when the ECM motors first came out, everybody said, oh, as soon as you put that ECM motor, you're getting SEER too. Well, we're not using just the regular 3-speed motor. We want the variable speed motors, if you will. We just see the benefit.
My question is, Alan, what static pressure range do you operate in? What's the
Uh,
high static pressure that'll take?
Oh, gosh.
Traditional?
Yeah, you're
1
more.
inch. You don't want to go over 1 inch, that's traditional.
Yeah, we have them over 1 inch
You do.
in industrial applications though. And I can,
Is it a different motor or is it the same area?
no, it's the same air hand. Well, we go to the 3/4 usually, 3/4 horse on that. So
I'm asking specifically for mobile home applications.
I would probably,
Because those are high static.
yeah,
Those are over an inch.
I would probably go with a 3/4 horse on the ice.
So you're saying we could use that in a mobile home with a larger motor?
Yep, I put them in with the 1/2 horse too. And yes, the motor will last for X amount of time and then you're replacing the motor again. Just like you would with anybody else's. But yeah, you step up to the 3/4 horse and we don't have that issue nearly as bad.
What's gonna happen, that's a general question, maybe, or maybe not. We got this new law, we've got all this money coming for heat pump installation starting next year. We don't know all the regulations yet, we know a little bit about the outline. We don't know how much money Missouri's gonna get, but what I'm hearing is the Ameren program is gonna go away.
Yep.
That's what I'm reading, and it's all gonna go to this federal tax credit program. Will there be any benefits to the Cocoon with this new program?
So from my understanding on the new program, and please, I'm not up 100% on it, it becomes a system rating, or if I understand this correctly, when you commission the system, that's the data that you're sending in order for the rebate. Because, everything looks great in the lab. As soon as you turn around and put it in somebody's house, that changes everything.
Be a SEER too.
Exactly, and so that's where I think that new is coming in, where it's supposed to be commissioned ratings and not just lab ratings anymore. I don't know that 100% for sure, but yeah, that's kind of the last conversation I had with them on. So this is a picture of so this is a three-phase system. We can do three-phase. That becomes built, if you will. You just gotta let us know whether we put a transformer on the side of it. Like this here, the three-phase transformer. But yeah, so this is actually that's how I got to market first, was through industrial, because I didn't have to have a UL listing and all that stuff. Really, industrial becomes a tool. So we did hot rooms for Spectrum brand chemicals, where they would bring in their chemicals, heat them up, so you get, when they start to mix, they get certain viscosities, all that kind of thing. Or in this case, this is a batch oven, like same thing, a chemical company, where they turn around, they put their chemicals in there, heat them up. And I think they were running this one at 109 degrees, and the other one was like 105, 110, somewhere around there. As you heard in the video, we do get gas-like temperatures out of this. It's not uncommon for, depending on the furnace, for us to see anywhere between a 40 to 60 degree temperature rise. Most of the time on your smaller systems and the 2000 systems, you're going to be running on startup, or when the front blower kicks on, right around about 110 to 115. It'll drop down a bit, and then it'll actually continue to rise for 2 hours. Okay. So those panels in there do not get saturated with heat, if you will. They can continue to gain heat for up to 2 hours. We didn't know that until we went through the underwriter laboratory testing, because in UL 1995, they say your furnace has to maintain a steady state before they actually start taking their temperature readings. They had all kinds of sensors on the outside and inside and everything else. And I told them, I said, there's no reason for this furnace to run for 2 hours. I haven't seen a furnace really do that, short of changing it out and it's 30 degrees in the house. Well, then it might, or something like that. You're going to get an extended runtime. But we actually kind of gain efficiency, if you will, the longer the furnace runs in regards to that, because now those hot rocks have a lot more power stored in them that you can now release into the house.
So if I can summarize, because I gotta, when I talk to my dealers are here, but we're not generating extra energy that really just creating light. We're generating at a lower end of the spectrum or a higher end of the spectrum, where we're just creating all the energy is going into those heated panels. And that's why we're saving 41%.
It's heated paint. Well, it's not just the panels, it's a combination of everything. If you just do the panels, you're getting an incremental savings. That's it, not much. But so either that power that normally would have been light is either going into the panel itself or going into the airstream. One of the two.
When I take this, maybe, and I don't know if it covers, that furnace right there is an equivalent to about a 20 kW standard electric furnace. Is that correct?
Yep.
And what size breaker do you need for that furnace compared to a 20 kW electric furnace? That's
a good
what's
question.
common. That's what's going to hit home.
Yeah.
A lot of my dealers ask me all the time, Alan, they'll say, I don't have enough amps. The panel's not big enough. So yeah, that's a good question.
So that's why we're doing so well in Europe right now, is because most of the services are like 100 amp services. So with this furnace right here, you're going to be a single circuit to it for like roughly that 20 amp instead of 2 or 3 circuits.
So what breaker size?
Yeah, so breaker, we're going to breaker it at 60 amps, and then it's going to run at 45 amps.
Okay, there's your common sense. 60 amps for 20 kW or 120 amps for 20 kW straight electric heat.
Yeah, you've answered that where you go forward.
Yep. Yeah. I mean, our test data showed closer to 50% energy savings. When we tested with UL, they tested at 45%. We agreed on that 41% because I knew it was so disruptive, in itself. That was it's almost too disruptive because, I get the guys with the alphabet soup and everything behind your name go, oh, you can't do that. You're breaking the laws of physics. I said, no, we're not. We're just using physics in a different fashion that nobody else has done, And I kind of like try to say, remember the days when we had a single stage gas valve, then all of a sudden there's a 2-stage gas valve. Wait a minute, you're using less electricity. This is the evolution of electric heating that we get right down to.
That's a big thing. I'm glad he brought that up. Because I hear that.
That's what hits on like your 1,800 to 2,200 square foot.
Yeah.
Amperage.
That'll
I've got a $150 amp panel, I can put that in, where if I need to, I'd have to upgrade the panel. If I put something that.
Right, right. So you're already with your installation costs, you're gonna be quicker. You're gonna have less installation costs. You're not running two, you know, in a new home, you're not running 2 or 3 circuits, you're doing 1 circuit. Now, you get into the 3,000. Still have that now. You get into the 3,000, you have that option. If you have the space in the panel, sure, you could run 3 circuits to it. Otherwise, the 3,000 is going to be 2 circuits. You know, because of the what we do with the second chamber, how we keep that down to how we keep that down to 1 breaker size is when you put this second chamber on, these 4 panels in here, I alternate them every minute and a half, you know, through this controller. And so that keeps me under that amperage that I need. Again, heat's compounding. So as you continue to heat those panels up, they just keep rising in temperature and keep going. And it's like a stair step.
Well, do you have a panel that you can pass around and show these guys?
I don't have any here, but totally, please come up and take a look at the furnace. And the panels themselves are about anywhere between 6 to 8 pounds, you know, kind of depending on which panel it is. You know, that was one other thing I was going to say. If you guys are doing an attic install, or just how about, I don't like carrying heavy things, period, anymore, especially with my back the way it is. You've got two L clips, L brackets in the front, and then in the back, there's a strip that stitches the 2 boxes together. You can take it apart, remove, like I said, the blower wires. Now you're dealing with a 75-pound box or 45-pound blower box. I like that a lot better than having to move a, you know, gas furnace or whatever the case, that's going to be 200 pounds.
Looking for a real world application. Okay, who is your best customer? Why? What is the solution that they are coming back to you to solve?
Well, that's kind of, so I mean, we're hitting the worldwide market, you know, but right now it's replacing oil furnaces in Newfoundland. Newfoundland just built a new power plant. Right, the only place you can get a rebate on our furnace, unfortunately, is Newfoundland right now, because they want to get off of that oil, and so that's why, you know, they're looking at that, and that's where we're working with DOE at as well, saying, hey, look, you know, we've got something new. You guys are, you know, get behind us, you know, on this. We can help the energy crunch that we're seeing in America. But yes, as far as real world, even on the East Coast, it's right now it's replacing oil furnaces. More so just because there's a bigger push, if you will, in those areas to get off of that oil furnace, if you will. Otherwise, too, gosh, if you get out away from, you know, St. Louis area, you know, what are your choices? Electric, heat pump, or propane? You know, and we're not competition with the heat pump. You pair us with a heat pump. You know, I mean, that's right. You're getting the best of both worlds at that point. And so when you start looking at that in your surrounding areas, you start getting into rural America, that's the other place that we're doing well because, well, they've only got 3 options, if you will. We have a lot of people, which I'm sure you guys have seen this too, just don't like gas, right? You know, you go into the customer's house and they just don't like gas. Well, now you can give them an option, which people rave about our comfort. You can give them an option that's going to give them gas-like temperatures without all the kaboom. And that's a big deal. You know, that's another area that people are really starting to pick up on, more so on the East Coast right now than anything. Any other questions or?
You ever thought about making a regular air handler where the oils underneath and it's all like grooves?
We've got a lot in the making here. So, because this isn't just a new furnace, it's a new technology if you get right down to it. Yes, I can't talk too much unless I have you sign an NDA, but we're looking at water, we're looking at commercial, 100% outside air. You know, we're trying to, the other area that we're kind of having some success with is warehouse heating. These big companies who build those big, massive furnaces, if you get right down to it, mainly they're using direct fire for that. And now because of the electrification, you know, we don't want that. What else do you got? So that's where I'm at right now, is really trying to get the technology, if you will, in different segments of the HVAC market.
kind of nice to have like a max set up where you can just buy the whole area and run the coil in.
And I'm crawling, walking, then running. But yes, yeah, absolutely. It's all on the, just try to get from point A to point B as quick as we can. And, right now it's, I'm just trying to take market share to get right down to it. Because it's not if, I've learned when you have something like this, it's not if you're ripped off, it's when. And, so I want to get out, take market share and then, deal with the knockoffs as they come.
What about a horizontal application?
So you can install this horizontally. If you do, the limits that you have, so we have double limits in here, your thermal limits. The top, like if you take this furnace and lay it down this way, those top limits have to come out and you run off the bottom limits at that point. So there is a little bit of an installation aspect, but I like to put them vertical myself, when I can, but I know you run into issues where you can. Because actually what happens when you take them sideways and you take that panel down, that heat comes down and it kind of starts to heat back up, and then that top heating panel stays a lot hotter than the others. And that's why you got to remove those limits out of there and run off of the bottom limits. We're not having to worry about the jacket overheating because of the air movement that's kind of through the wall of the jacket itself.
Can you set these up with multi-stage air conditioners?
Yes, so like we do it with multi-stage heat pumps too. Right now, to hook, like your stage 1 is going to go through our controller. Your stage 2, you're just going to hook directly to the motor. As far as tie it into the right motor lead, and then there's your stage 2, or vice versa, whatever it's going to be, whatever your 60/40 is, or whichever one comes on first. Any other questions or comments or? Well, I again, thank you guys for allowing us to come out. If you need it or got any other questions, please, reach out to your sales guy and they'll get with us and we'll make sure that we get your questions and everything answered. We're going to see if I had anything else on here. Oh, just so you can kind of see here. And I'm sorry, I don't remember your name. Mike. So here's our 2-chamber system. Again, it's just sticking another heat, I've actually stacked them up where we got 4 on there, but that's for industrial purposes. We, at that point, you start getting into issues with too much temperature and hitting over the 200 degrees that UL says we cannot do in ductwork.
Or you got stackable boxes that go up.
Yeah, if you look at the top here, you can kind of see these little nubbins. And so the box will actually fit right on there. It's not like you're having to hold your tongue sideways and screw it together or anything like that. It fits right on top of there. Again, just like building blocks or Legos. That's yeah. That's just
What's the capacity of the blower and the small?
So it's the same blower. It's just how we program them is what it comes down to. So with those, we can program them, the generation 2, we had 5 speeds in there that we would program, and it would basically be at 2, 3, and 4 ton. And then, the other 2 speeds we would, utilize for heating or, different aspect from there. But that's kind of how they come out set up, if you will. You've got a 2, 3, and 4 ton application, and then your other 2 are going to be for your heating speeds or whatever. Same thing. I don't know if you guys have those controllers or have those programmers, but I know Nidec, they have like an app you put on your phone, you plug it into the motor. So if you're in the field, you can turn around and actually program the motor and everything too. See what RPM it's doing and all of that.
What about the widths on the cabinets? Is that like the smaller one? Is it like 17.5?
17.5. Yeah. If you're going to do like a 4-ton coil on it, of course, you're going to need to do a transition. Or like a 5-ton coil. What we've done in the past to hit like a 5-ton capacity is that we would do a 5-ton coil. So you're getting the BTU capacity of the coil with a 4-ton condenser. Of course, there's no AHR on this, but 4-ton condensers, that way you can keep your pressures up higher. And then you're still getting that 5-ton capacity out of it. And that's where we're running about 320 CFM, 325 CFM per ton.
Can these be twinned if you so would need to?
I'm sorry?
Could these be twinned if they so needed to?
Yes, yeah, there's, and actually we got a couple of things with the twinning there to where we don't quite have it live yet, but to where you can plug the Cat 5 into each one of those controllers. And then they talk and all that stuff, but we're not releasing that quite yet, but otherwise, yeah, we're just like you normally would 20 other furnaces.
Okay.
Any other questions or?
We have one that's in the field now, and the biggest complaint was the contactor noise. Like it would wake them up and that never popped on in their condo, because it was so close to their bedroom. Is there any other option?
Yeah, solid state contactors. You know, we had the same issue where the guy, so his living room and his mechanical room was right there. And of course, his return was right there too. And what we did is we turn around and just replace those with solid state contactors, and you don't have to worry about that. Most of the time, you know, it's like maybe 1 out of every 100 we're seeing that or something, you know, because they're sitting in the basement, you got the door on them. You know, yeah, you might hear the pop of the contactor, if you will, and then that'd be about it. If they're buzzing, you know, I mean, it's just like any other contactor where, you know, okay, if it's buzzing, you tell them to cycle it, and it'll usually stop it at that point.
Why wouldn't you just put the solid state ones on?
There's about a $75 difference between each contactor. Yeah. So we go from, like, you know, call it $24 in contactors to 200, you know. But, and that would be an area where if it is like that, you know, yeah, you talk to them, okay, hey, we can put this in here, but if you want the quiet aspect, it's going to be an extra, you know, just charge them the extra, you know, whatever the difference is on the contactors.
I had a question texted me about 20.
Yeah, we just covered that.
Okay.
Yeah.
Okay, well, it came in while I was on the phone out there, so.
Yep.
Now, you can or you can't?
You can, yes, you can.
You can twin your ECM motor?
Well, it's basically you're running the two of them at the same time. is
Right.
Yeah, it's gonna come down. to
Right.
it. You're getting the call for, you know, your both.
You mentioned actually cooling the rocks. How do you do that?
So put the A coil on the return side. And, you know, or just draw through those rocks, if you will. And then, so in the controller too, so if you have an A coil on your return, you don't want to continue to run that. So what we do is, as soon as the thermostat's satisfied, we shut everything down, and you can program it in the controller. We'll shut it down for like a minute or 2 minutes to drain the water out of the coil, so then you're not putting that humidity back into the air. And that setting is in there, so you can drain it and then turn around and then, you know, run it again for another 4 to 10 or whatever minutes after that. That, you know, that's settable too in there as well. Anything else?
On your thermostat, so you just keep it at a normal fast heat cycle versus slow heat cycle.
Yeah, so like I like pairing up with the EcoBees. The problem that I found with the EcoBees is that you're not going to set this as a normal electric furnace. And to set up an EcoBee, you're going to set it up as a boiler or a gas furnace. You want the furnace to have control of the fan motor. We are not wanting to energize G during the heating cycle. The furnace will still run. Problem is it won't get as hot. And then, you know, you're pushing too much air at that point, you know, because you're running the fan 100% basically. Right. And so, yeah, that's the difference that we've seen is that, you know, you just want to make sure that when you're setting it up, you want to make sure the thermostat or the furnace has control of the fan, not the thermostat.
So you want to pretend it's a gas furnace.
Exactly. Yeah.
Because I know if you do boiler heat, that's actually a slow heat cycle, so that's going to actually change how it operates.
Yep.
It brings on less the unit control when the boiler turns on. It's going to be a longer heat anticipation.
Yep.
So then with that on the off cycle, could you still recommend leaving the fan on continuously to get a little bit more residual heat?
Well, that's where you set that in there during the commissioning side. So like, let's say you put the furnace in, you know, and you're firing it up for the first time. Take your return air temp and your supply air temp. And then you wait let the furnace run for about 10, 15 minutes, somewhere in there, and then take your temperatures. And if you're seeing, you know, I like that sweet spot of about a 40 to 45 degree temperature rise. Anything more, like if you did a 50 degree temp rise in this, Well, okay, it could be because you got high static, it could, a number of different things there. Well, at that point, if you're running a 55-degree temp rise on this, up your airflow, get it back down to that 40, 45 degrees, right around in there. But yeah, I mean, you want the furnace to have control of that. Did that answer your question?
Trying to think of it. I'm more or less talking the off cycle.
Oh, off cycle.
Yeah, because you were saying that holds some heat for about 20 minutes before it's back down to
Yeah.
0. So if I have my fan on continuously, my system's gonna cycle off, but I should still be putting some heat into the house. It's obviously gonna start cooling off.
Exactly.
But I would think that will help keep your ebbs and flows a little bit even tighter at that point.
Yeah, so like on the off cycle, I mean, you can adjust that in there, and that's where I was going, is that you want to see, like, let's say you turn around, let that furnace run for 15 minutes on your commissioning. And then after you're done, and we do have a commissioning sheet in the back of our installation instructions too. As soon as, what you're going to do is sit there and go, okay, look at your temp drop at that point. Once you hit, I like to shut them off about mid 80s, somewhere in there, 84, 83. And what I'll do is I'll start my timer, go, okay, the furnace is now running on cool down cycle. Where did we hit that? Here's the time, and then that's the new time that I input into the controller. Now, if we got a call for heat, let's say it's a real cold day or whatever, and we're in our cool down cycle, the furnace will automatically make sure that it does a minimum of a 3-minute runtime. Because you can actually sit here and cycle the furnace for up to 8 times, if you will. Depending on what your startup time is. If it's 3 minutes, you're going to run, as soon as you kind of hit about that, call it maybe about the 6th time or so, you're going to start seeing that temperature rise up to where you could start popping a limit, that kind of thing. But if we get a call for heat in the cool down cycle, we kind of clear the chamber, if you will, and then we turn around and start the program over again. So we do have some built-in redundancy for that. All right. Well, again, I thank you guys for having us. We'd love to do it again sometime. And if any questions, please let us know. Or any ideas, love to hear them. Thanks.
Thanks a lot.
Hey, thank you guys.
Appreciate it. You looked up, yeah, but you're gonna put them in, if you get us a certain school.
Yeah. Oh, yeah. We're doing. Yeah, we're doing.
If you know it a little better, you probably sell me, like, if you know it. You'll, sell it.
Yeah. Oh, absolutely. Yeah.
Good question. Should I ask you put in? I don't want to walk away. That's really. So it was. Different.